assignment is going to be C and C++. You're going to be programming both. Really, the fourth assignment, you're going to be doing the same application twice, once in C and once in C++. The fourth application is primarily going to have to do with file manipulation. We're going to do some file manipulation in assignment 3, so that's what this is going to cover as well. I guess then the question is, what is a file? Data? File is data. It's right. It's a data store. It's an excellent answer. Slides across the classroom. So, if I draw a file like this, what's inside of that? All the data. What's our goal when we have a file? Read data from it, put data back in it. That's excellent, right? Why do we want files?
Permanent storage.
Permanent storage of what?
Data.
Data. Right? And so it's not necessarily about the organization of data. We can organize data different ways inside of files. Really, if we're talking about the organization of data in computer programming, that's really what CS310 is about. That's data structures. We can save data structures to files, but usually that's an entirely different way of thinking about the problem. Really what we want to think about is files are permanent data storage. So if this is a file, here, this is permanent. Where do we usually put files? Or where do we usually think about files as being? On the hard drive. What's special about hard drives? Besides being permanent.
They're especially slow to access.
Say that longer. I didn't understand your sentence.
They're really slow to access.
Yes. Hard drives are especially slow. I think that's what you said, right? They're very, very slow. So if this file is on the hard drive and I want to access part of it, it's going to take me a long time to access this. In today, well, not today, since about 2010, I guess, a new technology came out that is replacing hard drives, solid-state storage, SSDs, and those things are significantly faster. However, solid-state drives are still, compared to RAM and the CPU, very, very, very slow. The example I use in 237 is kind of like if I want to access RAM, it's kind of like walking from the front of the classroom to the back of the classroom. If I want to go to a hard drive, it's like walking to Japan. It's very far. It's huge. The amount of time that we're talking about and the differences in the number of calculations. For example, if I want to access this particular file on the hard drive, on a hard drive, not on a solid-state drive, usually this will take 7 milliseconds, 10 milliseconds, just before I can even find the file. So this is the latency time, or the spin-up time for the drive. Once that's happened, then actually reading the data off the file can take anywhere from a couple of milliseconds to hours, depending on how big that file is. If I need to be able to search to the middle of the file, and I don't know particularly where in the middle of the file I want to be, this could also take a very long time, particularly if the file is compressed or encrypted. So these things, even though they're permanent, we don't usually, except for in very large situations, we don't usually want to deal with files directly, except for in two situations. What are the two situations we want to deal with the files directly?
Saving and loading.
When you load the file in from the hard drive to where? Where would you put it from the hard drive? In the RAM. So really, we want to be able to take our the file, and we want to be able to load it to a location in RAM. So we want to be able to take all this file, we want to stick it somewhere in RAM, in our memory. So we're going to stick all the file's contents inside of the memory, and then once we've finished loading it, we want to then close the file and not deal with it anymore. If you're familiar with things like Microsoft Word as an example, when you open up your document, that entire document is loaded into memory. You make changes. If you force quit Microsoft Word, are those changes saved in the file? The answer is no. If Microsoft Word crashes, your changes aren't saved. Now Microsoft Word does have a recovery feature, which is pretty neat. But prior to the recovery feature, if Microsoft Word crashed, you were shit out of luck. You couldn't get your file back or any of your changes. The way the recovery feature works is that what it does is it opens a recovery file and saves to the recovery file every couple of seconds. because modern hard drives are fast enough to allow us to do that. But in general, that's not the way our applications want to work. We're going to load the entire permanent memory or permanent file into storage, and then at the end, we're going to write it back out after we're done with it. We're going to load and write, load and save. Let's say save down here, load up here. That's the typical processing mechanism. The other reason why we want to do this is most operating systems have limits on the number and kinds of files that we can open, and how many processes or programs can access one particular file. An example of this would be a web server that wants to host an image, and you want to send that image, like let's say it's a picture of a cat, and you want to send that cat to 10,000 users that are all accessing that cat from Reddit. How do you get that image to all those 10,000 users is a problem. And so if we tried to have 10,000 programs all access that one cat file simultaneously, it's going to fail. So what we end up doing in the way what web servers do is they access that cat file once, maybe twice, they load it into memory, and then serve all those 10,000 people out of memory. Because that hard drive for each of those 10,000 people is going to be very, very slow. Even when you consider network storage or internet connectivity issues and whatnot. This is a common practice. This is particularly true during the saving stage. Most operating systems do not allow two programs to read and write the file simultaneously. So if you have program A, and program B. If program A opens for writing, open file for write. If program A has the file open for write, then all access to that file is denied. Reading or writing. This is common. This isn't always true, but this is fairly common. So you think, hey, if I want to save this file, if I want to write to this file, all the programs get denied access. When would this be an issue? Or when would this be difficult to deal with? Databases are a big part of it. And so databases, you want to be able to read and write to a database simultaneously. Sometimes you want to have different programs that are reading and writing to it. And usually we can't actually make a database that is multiple programs. What we end up doing with databases that want to read and write to a particular database file, we end up writing a database program. And that database program is the only program that has this file open for reading and writing. So when you talk about things like MySQL or Postgres or Couch or any of these other database programs that you've heard of, they're the only program that actually has the file open for reading and writing. Every other no other programs open those things for reading and writing. They ask the program that is running to access that file for them. And that's the way they do that. There's another situation that's maybe a little bit more common. Maybe less common now. I don't know. It used to be more common.
Having a document open and trying to
Yes. Yes. So if so that's a situation where if you're trying to save a file and send it to use it in a different way, that's an issue. And so, which operating system are you using when that happens? And what programs are you using?
I'm like still typing up an Excel document.
Ah.
And like trying to send it to my boss.
Okay. Is that on Microsoft Windows? Yeah, they should have fixed that by now. But
It might have, but I remember it being a problem.
yeah. So that's another kind of an example that's straight out of work right there. The one that system administrators have the problems with is with logs or with logging. So logs are supposed to keep track of everything that happens on the operating system. A user logs in, you write it to a file. This user A logged in. Well, what if you had another program that was supposed to be reading that file to keep track of who logs in and who logs out? Because that's the only way that you do that. You're a firewall that's trying to keep track of which programs are open and which programs are accessing the internet. If you have a log file, it's difficult to have them opened by a different one and written by another. And so there's some mechanisms that operating systems have since allowed to allow both of those things to happen, but they're restricted in a way. I do not know of any operating system, actually, off the top of my head, that allows two programs to open it for writing simultaneously. That is definitely not allowed. And that's because we don't know which one should happen if they don't try to do a simultaneous write. When we say simultaneous write, it's difficult because we don't know which one's first, we don't know which one's second. What if they write to the same location? If you're using a program, something like Google Docs, like two people can be editing the same document at once. That's an entirely that's a distributed networking problem. That's a distributed solution problem. It's completely separate from files. And really, even when you're doing that distributed networking solution, you actually have an application that multiple people are using, and only one version of that application ever reads or writes the file, which is kind of an interesting way to look at it. And really, they use a database. They use a MySQL database to do the reading and writing. There's really only one program that actually has the file open, even though everybody's using it. So that's one way that they get away from it. Databases are the biggest way. So since we've already mentioned it, let's say we have a giant file. Let's say we have a database of, I don't know, all the cat pictures on the internet, like Google does, and you want to be able to search by cat picture. Be like, this is a cat. Has this cat been posted on Reddit before? How do those reverse image searches work and things like that? Well, if you have a database of all of the cat pictures, that database is going to be terabytes in size because there's a lot of them. And we don't quite yet have computers that have terabytes of RAM, so we can't load all of it into memory. This is still true for things like, let's suppose you're watching a movie, because I know everybody knows how to download movies and watch movies. I want to load that movie into my computer's RAM. Well, might not have enough RAM to load that Blu-ray rip that I downloaded. If the 16 gig Blu-ray rip, I don't have enough RAM to do that. How do I get part of that file out? And so then you get specialized programs. And media players are specialized programs that operate very similar to databases. Databases are the other way they do this, is that they have specialized algorithms that read and write in sequential order. We'll talk about, we could do it ourselves, but usually we don't want to, is the answer. All right, let's look at some C things. Has anybody looked up C files yet? No? All right, cool. So C has, the data structure that we're going to be using is the file, or not the data structure, the data that we're going to be using is the file pointer. And so we're going to have a file, it's all caps actually. We'll have some file pointers. And so F-I-L-E right there, is that a primitive data type that we know about? No. So what do you think this is? It's a struct. That's exactly what it is. It's a struct of some kind that's going to keep track of all the file information for us. What does that star mean again when we do the declaration? It's going to be a pointer to a struct. That means at some point in time I have to do what? Malloc and free at the end, right. So if I have a file star, let's call this monkeys. I know what the answer's going to be, so it'll be monkeys. We have our file star monkeys. That monkeys variable, the variable itself is placed on the stack. It is a pointer that points to a location on the heap. When we use this program, when we use files, we're not going to be doing the malloc. We're going to be using some function calls that will be doing the malloc for us. Does anyone have a guess at what that function call is going to be? Excellent guess. So we're not going to be doing a malloc. But we know that a malloc will be happening inside of it. We're not going to have to look at it. And we won't ever see it, which is excellent. But we know there's going to be a malloc be done inside of it. But what are we really trying to do in this case? What's the normal term with files? We want to open a file. And so fortunately, there's this function called fopen. And fopen is a function that opens a file. And inside this fopen function, what it does is it does all the necessary work to find out where the file is on the operating system. It does all the necessary work to malloc the space for the file, for not all the file content, but for the file structure, the file structure here. As an example, we could have, the first argument is the name of the file, so we'll open bananas.txt. That's not whose folder that is. There we go. .txt. And the second argument here is the mode, the file mode, how we want to open it. There's several different file modes. There's reading, there's writing. What else do you think there would be?
Edit.
Reading and writing, and delete. So there isn't a delete. There is a way we could truncate a file when we open it, but that's not really deleting. It's a different concept.
Edit.
So it's not execute, because execute means to run a program, and that's a special command. It's exit. The exec function is that. It's the other kind of thing. So it's a form of writing. It's a specialized form of writing.
Edit.
Append. So append means to write to the end of the file, whereas write means to start at the beginning of the file. So we're going to start this with a read. So this is just going to be a lowercase r. When you look up the documentation, you'll see what all the different versions are. There's read, read plus, write, write plus, read, write, A for append. I think there's a couple other modes that aren't particularly as used as often. But those are the basic ones. fopen returns a file pointer. So in this case here, I'm going to say monkeys equals that. Now, this file pointer does not contain the contents of the file. It only has the information necessary to get access to the file. We haven't actually done anything with it. I opened it here for read access. That means I can now read from it. The standard way that we're going to start, there's many ways to read file stuff. And so if the way that we're going to talk about today doesn't make a lot of sense to you and you can't get it to work, that's okay. There's other ways to do this. There's tons of different functions that give us access to it. We're going to use the fscanf. So we've already used scanf, correct? And scanf scans what? Standard in. fscanf is going to scan an arbitrary file pointer. So we're going to use fscanf. And the first argument to fscanf is going to be the file pointer that we want to scan. In this case, it's going to be monkeys. Like so, with a comma. The part in the middle here is going to be the format string that we're going to be scanning. So let's suppose that it's a string followed by 2 integers with space in between them. So let's be a %s, %d, no comma, sorry, %d and a %d, like so. And then what happens after the format string? The variables and the pointers that I want to put these things in, right? So, for example, I don't have them declared yet, but I could pass in the buff here, and I could pass in the address of 1 and the address of 2. So 1 and 2 would be the integer 1 and the integer 2. Yes?
So the file that you're passing in, it has to match that string, right?
Correct. So
like, what if you had a string and 3 decimals?
So
Or 1 decimal?
that's an excellent question. So that's exactly the question I wanted you to ask. Excellent job. What is this string called? I just said it like 30 seconds ago. Format string. This is the format string. The format string defines the format that we will be reading, right? If I change the format string there, what am I changing? The format that we're going to be reading. When I write this, I am defining the format of the file. That's what I'm doing. Okay? If the file is a different format than this, can I read the file? No. Because this format string defines the format that I can read. If this is the only format string that I have in my program, I cannot read any other file. So when we talk about file formats, this is what we're talking about. What is the order of the data in the file? And how should I read it? So for example, if I'm opening this file here, what's the format? It's string, integer, integer. So if my file contained high 3.147, that format and that format don't match. My program cannot read this file format because this file format is different than the format I'm expecting.
Yeah, that was pretty much it, just because I realized that C kind of takes a lot of stuff that shouldn't take, but why in this case does it?
So because I'm specifically defining this to be my format string. There are other ways that I can read the data that don't rely on format strings. I can write this, I can use this a different way that wouldn't rely on the format string.
So, but if you still had like string, 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 it's going to treat those two as strings anyways?
Correct. It would treat these two as strings, and I could read them. So the answer, so if I did %s, if I did %s, %s, and %s here instead, and I had buff1, buff2, buff3, all three of it would read this format successfully because all three of those would be strings. That's true. Right? But then the data format, what's this thing would be kept as a string or a char array in my program, not as a float. And so if I wanted to do float math with this value here, I can't do it with that string.
Also, you're probably definitely going to answer this. So are those arrays now?
Buff here is an array. 1 is not, 2 is not in this
So
case
if you
here.
have like,
We could just have two variables, int1 and int2.
I guess I mean if you have multiple lines.
Ah, in the file, right?
Yeah. That's
Ah, okay. So that goes on to our next question. How much does this read? And the answer is this reads exactly that many things. So if our program needs to read multiple files, I have to have either multiple places for me to put my data, or I have to parse the data differently every time. So I have to be parsing it every step. Those are my two options. Either I have to be able to hold all my pieces of data, or I have to parse it every line, and then throw it away. When I say parse it, I mean, so if I don't, let's say 1 and 2 are not arrays, so I don't have arrays full of data, I just have two variables here, and I have multiple lines in my text file, so I have hi, I have by, let me change this just to a 3 here, and I have a 10 and an 11. If I just have the two integers, and I'm reading them as integers, not as strings, then I have to be able to completely finish my high, my 3, and my 7 completely, and then throw them away so I get the by, the 10, and the 11. And then I can completely finish those and throw away, and then do the next line. Completely finish those and throw away and do the next line. When we're talking about video players, that's how video players operate. What they do is they read some part of the video file off the file. They read them, they render it to the screen, they throw that data away, they read the next part of the file. They render it to the screen, they throw that data away, they render it to the file. That's the reason why some video players, when you click back on a video, it takes a second before the video will pop back to where it's supposed to be playing. Different file formats require different amounts of reading and writing and throwing stuff away. And that's based upon what the file format of the video is. Good?
Why does that? Does it depend on a certain algorithm, or is it simply different?
It depends on the file format itself. So for example, if we're using a file that's stored in H.264 format, as an example, H.264 is a definition of a file format. That's what that means. And so H.264, if I look at the bytes, doesn't have anything to do with the pixels on the screen. But when I run it through the algorithm that turns the H.264 file format into pixels on the screen, then those pixels I can display those pixels. And H.264 defines block sizes. So let's say it defines a block size of 1,024 bytes. And so what it'll do is we'll read 1,024 bytes in. Here I read, I don't know, 5 bytes in, kind of deal. We'll read 1,024 bytes in, run that through a program or through an algorithm, display those pixels on the screen, read another 1,024 bytes. And so if you go back too far, H.264 is doing a different process. Other formats like, for example, DivX, as an example, and XVID, which are older file formats, they require that you do longer chunks. So instead of doing 1,024 bytes, they might be required that you do 10,000 bytes. And the second that you're, and the position that you're looking for is at byte 7,000. And so it requires you read 10,000, skip 7,000 of those bytes, and then play from there. Whereas H.264 requires a different subset. Cool? Yeah. Basically, it's the algorithm in the file format is what those things do. And so that's what we're doing here. When we write this, we define our file format. If our file is not in that format, we can't read it. So if you have a video player that doesn't read a specific format, it's because it can't read that format because it doesn't know how to read that format off the file. All right. Let's go ahead, and what we're going to do is I want you to try first. I want you to define a structure that will hold each row of our previous file format. Our previous file format, again, was %s, %d, %d. So I want you to define a struct that will hold that. There's two ways you can write this, and either one of them is acceptable. So I call this a struct data, in this case here. How many things do I have inside? 3 things, right? So I'm going to have the first one. What's my first one going to be? What's the %s? It's a string, right? Which is a character array, right? And so char star is a character pointer as well. So we could define it this way. We could define it as a char star. What's this variable you use here?
Hash.
What do you call it?
Hash.
Hash?
Hash.
Ash. Like ash ketchum? So that's one. So that's one way we can define that variable there. Do we get storage when we define our variable that way? The answer is no, we do not. What's the other way we can define that same variable and get storage? As an array. So for example, I have now defined the same character pointer, because Ash is a character pointer in both one of these. But this one here, I've defined 256 bytes of storage for it. Right? So those are both good. What extra step am I going to have to do when I define it this way? I have to malloc this one over here. This one over here, my storage is already declared. I have not declared any storage here. So if I want to use this, I'm going to have to malloc this. Over here, I don't have to malloc it. Yes? So, excellent question. So this character array will end up on the heap. And the reason why is because, it depends, actually. Wherever this structure shows up is where it'll end up. So this one over here, if this struct data ends up on the heap, this will end up on the heap. If this struct data ends up on the stack, that'll end up on the stack. This over here will always end up on the heap. Okay. Yes? Yes, and there's a big limitation with using this one. What's the big limitation on it? You only have 256 bytes. What if the thing you're trying to read in is 1,024 bytes? You can't use this one. So if you know the size is always going to be 256 or less, go for this because it's super simple. If you don't know the size and it might be really big, you have to do something like this. That's a important thing. Yes.
Why didn't we need the star for the second?
Because the definition of the array, like so, is this, it implies this star. So this is a char star. It just has its array the data, the storage declaration with it. Those are almost nearly identical declarations. They're both char stars. Okay, what's my next one? Int what? All right, int 1, and then I'll also get another int 2. And so this would be our structure. This is a good version of our structure. Either one of those two would be acceptable. Does anyone have a different version of this structure? There's one more version that would work as well. Is there a way I can get both of those together in one variable? Int, we'll call this data. Oh no, it's already called data. That's a terrible name. I need a better name than data. Barbecue? BBQ? So I've defined 2 barbecues. Barbecue action. Right, so we have our character array and our 2 variables. Or 2 variables, or we have our character array and our 2 integers. So really the idea is that you want to be able to have the string and 2 integers. It doesn't really matter how you define that data inside. Both of those are acceptable. I can also define this one as an int star, but I probably don't want to do that. Why do I probably not want to do that int star array? I'll have to malloc 2 ints. And that malloc 2 ints isn't really a problem, it's just another step for me to remember. And the other part of it is, am I ever going to have more than 2 integers? Not according to my file format. If my file format's correct, then I don't have to worry about it. And so then I don't have to worry about malloc. The other part is, if I have to malloc that, what do I also have to do? To free it. It's another thing for me to remember to free. The same thing with this guy up here. If I have to malloc it, I have to remember to free it as well. This is that process. If I allocate that memory, I have to remember to deallocate that memory sometime in the future. If I use arrays, that allocation and the deallocation happen for free whenever I allocate and deallocate the structure itself. All right, so let's take our structure here, and let's define a file format. So I'm going to define a file format, and I'm going to write an example file, and then what I want you to do is I want you to write a program that is going to read that example file format, or that example file format into the program so that we can use it in some way. The file format is going to contain, the very first line is going to be the number of lines, or the number of entries. So the file format is going to be number of entries, that's the very first line of the file. After the number of entries, then it's going to be a format of %s, %d, %d, however many number of entries there are. As an example, let's go ahead and say that there are 3, and there'll be something like cat, 10, 5, dog, 1732, and bird, 12, 18. I don't know if it's just making up stuff. We assign meaning to them. Cost and how cool they are. For a cat person, I'm sorry. If this was 10, there would be 10 of these lines. So let's go ahead. What I want you to do is I want you to write a C program that is going to read this file. You can assume that the file name comes in as the first argument, as the first command line argument. So you're gonna write a program that is going to read this file. It's not going to do anything really yet. It's just going to read this file, right? It's going to read whatever version of this file you get. The first command line argument is going to be the name of the file. And you have to read the file into memory stored inside of those data structures. Okay?
The name of the file be like
So no. So this is the contents of one of the files. This is an example file. This one is an example file. That's the file specifier right there. Right? So for example, if the first line was 10, that means you had 10 entries of that percentage. Give it a shot, see what you can do. Are there any other questions? Good questions. So I want you to try to hack it out. You don't necessarily have to write 100% great C code, but I want you to try to format all the different sections of the code. Let me push this over here. I'm going to assume that ash is 256 bytes. I'm assuming we can use this one. Please write this as a C file, not as bash. Bash doesn't let you do that. Structure that. What do you mean? So you don't know how many entries this number is going to be. This is just an example. It might be 10, it could be 1,000, it could be 5, it could be 0. Okay. Does anybody else have any questions about how to solve this? Does anyone think they have a solution or an overall solution? So what are the so instead of what code you've written, what are the big steps that you've solved?
You initially start off by opening the file, then you define the struct.
When you say you define the struct, do you mean this guy over here? Because this code over here defines the struct.
Yeah.
Right. So I'd actually put this right there.
So then you go and you scan the first line of the file into a variable that I need to know.
And first line.
And
Why do you scan the first line first?
because then I set it equal to a variable I call count, and then in a for loop for the number of times the count of the value of count, I go through and repeatedly scan each argument into an array of struct.
Before I loop, I'm going to put the loop down in the corner. So the big idea is that we're going to define some variables that's going to keep track of all of our stuff. We're going to open our file. After we've opened our file, we're going to scan that first line. Once we've scanned that first line, we now know how many times we need to loop. I wrote here prior to looping, I said allocate memory. When I say allocate memory, what am I allocating?
The number of structs.
I'm allocating some structs. I'm allocating a bunch of structs. I'm not allocating characters. I'm not allocating integers. I'm allocating structs. When I allocate a struct, I do allocate some characters and I do allocate some integers, but I'm not thinking about it that way. I'm allocating the struct, which does the other allocations for me. Which variables? So you have a variable called count, right? Let's say count. That's the number of lines, perhaps. What other variables do I want to define? So the file. I'm going to define this as FP is my name. This is the standard procedure. It stands for file pointer, FP, file pointer. Other variables. When I'm allocating my memory, how do I allocate memory? With a malloc, right? Malloc returns a pointer to that memory. That means I'm going to have a variable that's going to store the location of that pointer, or of that memory that I allocated. That means I'm going to have another pointer down here. What's this pointer type is that pointer going to be? The struct data star, right? It's going to be the type of the struct. So I'm going to say struct data star. What do we want to call this? Huh? Misty it is. Okay. So I was right about hashtag. There's other things you could have done. I didn't know if I was right about that. Let's go and open the file. There might be more data. If we need more data, we can go through and we'll figure out what it is. Does anyone have an idea off the top of their head what it would mean? When I do this loop, what kind of loop am I going to be doing? What do I need for a for loop? Int index, so I'll have an int I. Fortunately, when you write on a board, you can just kind of write everything. All right, let's open that file. I'll say fp equals fopen. That's it. Fopen. Where's my file name?
Argument.
It's the first argument from the command line argument. So that's going to be argv 1. Why is it not argv of 0? Because
Is the name of the
argv
file?
of 0 is the name of the executable, which is a.out or whatever you happen to be calling it. So for example, in assignment 2, when you compiled the file, the C files, you compiled them to something like 08CF59 or whatever the file was called. Argv of 0 would be 08, whatever that name of file was called. All right, let's open this for reading. We're not going to be writing it yet. Broke my setting. can't walk. Life is hard. Okay. Let's go and scan that first line. How am I going to scan that first line? We'll use the fscanf. Scanf. File pointer is going to be the first argument because that's the file that I want to be scanning from. What's the format that I'm going to be scanning for the first one? Huh? Just the first %d, just a single integer. That's all I'm going to be scanning. What if it doesn't start with an integer? I can't read that file. Where am I going to put that? Count. So I'm going to use ampersand count. Why do I have to use the ampersand there?
So you're going to the actual storage.
Right, so count is here, correct? The scope of count is inside of my main. Does count exist inside of fscanf? It does not. If I want fscanf, because fscanf does not have count in its scope, so fscanf can't touch count by name. If I want the value to go into count here, I have to give fscanf the address of count, so fscanf can write to this location, because the scope is not the same. That's why I'm giving it the address. If you don't understand why that's true, that's how you call it. That's the other reason. All right, let's allocate some memory. So Misty is going to become the struct data star of our malloc. What are we going to put in here? Size of what? So size of the struct data. So Misty points at struct data. We're going to be doing the size of the struct data, which is going to be all this memory inside of here. How big is struct data going to be? Huh? No, we don't. We don't right here. Tells us. 256 plus 4 is going to be 260, plus 4 more is going to be 264 bytes. Right? So that struct data is going to be 264 bytes. But I don't know that necessarily, so it might be. So I don't want to use the struct, the size of function. I'm gonna write that better. Size of struct data. What now? I'm going to use count, so I just write count here. Times count. I thought you said use count. Times count. Why times count? That's how many that I need. So, for example, if this was 10, I would need 10 of these lines, which means I would need 10 of these struct datas, which means I need 10 of these elements over here. What is this reminiscent of? That thing there and that malloc right there. Initialization. What's a class? Some data. It's an object, right? A class defines some data. We'd also define some functions over there. And then, how do I make an object for me to use? Called new. Right? So we're almost to the point where we kind of have classes at this point, or objects at this point. We don't have objects because our classes, we don't have inheritance or polymorphism or anything like that. But we have a data definition and an allocation of some memory. That's essentially what classes and objects are. We're going to see as we go through this class. We're going to learn more and more, and we're going to get farther and farther along this trail of kind of objects until eventually we make objects. You should be able to use size of straight out of the box without including anything. Yeah. Good question. All right, so I've allocated my memory for my struct data into my variable Misty. Now I'm going to write my for loop. I'm going to say for I equals 0. Oh yeah, I say int I equals 0 right there. I declared it up there. Why did I declare it over here and not over there? I can't declare it in C. If you've tried that, if you've tried this so far and you've tried to declare your int I inside of your for loop in C, you can't do that. ANSI C, which is what we run this Unix on from the 1990s, does not allow you to declare anything after the start of the function. You have to declare all of your variables in the beginning, and then you use them. This is one of the biggest things that Java did away with and C++ did away. You can actually declare an integer in the middle of your function. The idea is that when you have all of your variables declared at the top, it makes it easier to read the function because you know all of the data that's going to exist in that function. As opposed to maybe if I declare something in my middle of my function and I don't see it, it's easy to miss. However, declaring all of your variables in the beginning of your function is a little bit tedious. So that's kind of why we did away with it in C++. There's also the first compilers. The very first C compilers didn't know how to declare a variable in the middle of the function. Once it got to the middle of the function, you couldn't declare more than it. First compilers weren't as good as they were. Technically. I is going to be less than what? Count. I plus x, like so. How am I going to get the information out of that file? By fscanf. Like so. My string is going to be that same string we used before with the %s and the %d. And the %d. So, where am I putting the string? I want to put it inside this ash thing over here, right? Is Misty a single struct data? No. Misty is an array of struct data. When I do this malloc, Misty is now an array of struct data. The size or the length of it is going to be count. So for example, I think about it from 0 to count or valid entries. I go in and I say Misty of what? Of I. Because I is going to be the 0, then I is going to be the 1, it's going to be the 0, the 1, the 2, the 3, the 4, each one of those elements. Misty of I dot ash is where I want us to go. Oh, we do. I'm sorry. Excellent question. There we go. Is that better? Sorry about that. Absolutely correct. Yes?
So every time you do get fscanf, it knows to read the next line.
That's an excellent question. The answer is no, it doesn't. And we're going to look at some of these things and we're going to figure out, and we're going to see if we can make it fail and not fail and why, and what's going on. And it's actually really important that we understand why it'll fail and when it doesn't fail and what the different parts do. fscanf, if I put a space in the beginning, it'll skip all white space. And new lines are considered white space. If I put a space on the end, it'll skip all white space after the fscanf. And so it'll skip all the white space until the next thing. And depending upon how I do it, I can make it so that I don't have to worry about it. I either put a space in the beginning or a space on the end, and it will read line by line, simply because I don't have anything else on those lines. If I want to be able to read a string to the end of a line, there's a special character that allows me to do that. And then if the next line is going to be the same, or the next time I read is going to be another thing like that, then I have to have I have to be very cautious of where my white space is in my format. Right? And so technically when I do the %s and the %d here with a single space, there could be as many white spaces between the %s and the %d. These can be on separate lines, it doesn't matter. Right.
So how does it know, because you keep fscanf getting the same thing, how does it know to move from line to line?
So there's and we haven't talked about this yet. So when we open the file here, one of the things inside of this file struct here is a pointer to where it is in the file. And every time you run an fscanf, it moves that pointer past the last thing it ran.
Oh, okay, that's my question.
Yeah, and then it'll continue reading from that pointer.
Okay.
And so if you ever want to go back, you use another function called fseek, which will move the file pointer back. Cool.
So when you did the first one, it moved, so now the off limit past that. And so
Correct.
you started with the first line and then you went past that.
Correct. Right. And so you think about that file pointer is continually moving through the file until eventually it'll reach the end of
So
the
that's
file.
why you want to put a space at the end of it so that it would skip that white space and then point start at the new line.
Yes. Usually, actually, you don't put it at the end. You put it at the beginning of the
yeah,
next
so then
line.
it would skip.
It will skip everything and go down to the next
Okay.
line. It also has to be when you're doing it when you're actually reading an entire line. So when there's the command that you use to read an entire line, which we'll do as well, doesn't actually read the new line character. And if you put a space after it, it doesn't read the new line character either because of it's an idiosyncrasy of fscanf. And so you have to put the space at the beginning of the next fscan.
So the way that's written right now would fail.
It's possible. It depends on whether or not you consider that to be a space or not. But probably. We're going to see that. Yeah. So we get Ash. What are these other two guys going to be? That's a musty. That's a mystical. Misty of I.1 and a Misty of I. Let's see. .2. Something along those lines. What are we not seeing here? Or what have I not written that we might need on this fscanf here? We had that fscanf before, this one up here. What's this thing right there? What does that ampersand mean? Address of. Do I need the ampersand on these guys? Well, I don't know. Maybe I do, maybe I don't. But we're going to figure out why and why not, and what we're thinking about here. So whether or not we need an ampersand here, we're not sure yet. How do we find out if we need an ampersand on those guys? Try it. So this is one of those things is I could tell you, but then nobody's going to remember anyways. So I'm not going to tell you. What I'm going to do is I'm going to show you how to find out. And then once we've found out, then you'll know how to learn on your own and figure it out on your own the next time you don't remember, because you'll never remember this. And then the last part is, if I wanted to print them all out, I just have another for loop here for I equals 0 to I is less than connect. With instead of scanf, I would just do a printf and print each one out of the line. That's what I'm going to do is I'm going to put that for loop on. Are there any other questions before we move on and do this for realsies? Now let's do this for real. Is it still enough light to see your notes and stuff? What are we doing today? Structs? So I'm going to do this code up here that we have on this. We did on the board here. Oops. Oh. Keyboard is recessed and it's hard to read, hard to get to. What is something that I didn't do here on the board that I should probably do in real life? In the very beginning here. I'm sorry, say it again. Oh, I should put the struct thing in here. Yeah, that's true. What is something I should do in my program in my main that I haven't done yet, or that I didn't do over here? Free. We have to free something. We have to free both the allocated memory, and we also have to free what else? So that's the allocated memory. We have to free the what now? So we said over here, the file. We're not going to actually do the free on the file. We're going to use the fclose function, which will do the free for us. I'm going to chat with Ash. 1, 2.
Was struct data necessary before me or just good?
So in C, generally anytime before you use something, it has to be declared above it in a file. If it's not declared above it in a file, you can't use it. So the answer is yes. It'd have to be declared before the name. So our struct data, pointer Misty. What else did I declare? The int count. Is there anything else? I got the I. I think that's all of it. All right. So we'll have our fp equals fopen arg argv. That's argc, isn't it? That's argv. There's one more thing I should do before I use this argv. What should I do before I use argv here? Let me go and save this real quick, compile it. Then I run it. It's not crashing. It should be crashing. Why should this be crashing?
There's no file there?
Argv of 1 doesn't exist, right? I haven't passed an argument for it. And so if I tried to read, fopen probably fails. If I tried to use the file, it'll fail. One of the things I should be doing that I'm not doing right now is I should be validating that there are enough arguments. So I should have something like this. If argc does not equal 2, printf accepts one argument, which is a file. Like so. That's a percent. That's a new line. What does this kind of look like I'm doing here? So now when I run this and I compile it and I run it, accepts one argument, which is a file. What's this kind of look like here? Sorry? It's kind of like a try-catch. It's some sort of error handling, but so not the error handling here. So what is it? What does this remind you of? What if I do ls with a bunch of garbage there? What's that? It's an error message, right? What if I type in just grep by itself? Usage, grep, option, pattern, file, type grep -- help for more information, right? What if I try, what's another program I could do that requires something? If I say base name, I run base name, hey, base name, missing operand. If I run my a.out program now, A accepts one argument, which is a file. So when you're seeing these things, when you're seeing grep like this, what's the first thing inside of grep? Verifying that there's the correct number of arguments. What's the first thing in base name? Verifying that there's the correct number of arguments. What's the first thing in a.out? Verifying that there's the correct number of arguments. So this is an insight into the way that these programs are written. So when you look at how is grep written, one of the first things that it has in its C file? There's going to be an if statement. If argc is the correct length. One of the first things it does. All right, let's go back. Let's continue.
Is there a way that we could do in that error message just end the program running, or does it automatically?
I didn't end the program, so I can say return 1, because return 0 is success and 1 is failure in this case. This is one of the reasons why we want to think about 1 and 0 not being true and false, because 1 is failure, 0 is success when you're returning programs. And no, it's weird.
So if it reads return 1, it's not going to bother with the rest of the code?
Right. It'll skip the rest of the code. Because it'll return out of main. When it returns out of main, it's returning back to your shell. Here's our fopen, fscanf, scanf, fp %d into $count, like so. For I equals 0, I is less than count, I plus plus. We're going to say Misty of I. Oh, we're going to do the fscanf. I forgot about that too. fscanf of P percent S percent D Misty of I dot, what do we call it, ash? Misty of I dot 1, Misty of I dot 2. So, what am I missing here?
Struct data.
Yeah, so we're missing the allocation. So Misty is going to be the struct data star malloc of size of struct data times count. One of the things is in C, because C has a lot of stuff. When you're structuring your C malloc instructions, if you take your malloc and you put your spaces and you make your space, if you do spacing like that, it becomes easier to read your malloc instruction because your malloc instructions are going to be difficult to read in general. And so you can see there, I've separated out the different parts of it with white space so it's easier for my eyes to distinguish which parts are what. If you just kind of jam them all together, the compiler doesn't care. If you jam them all together, it's great, but the developers that are going to be working on it later aren't going to like you as much. You should probably do something as well with my fscanf there, but I haven't. So, all right, let's do this fprintf thing, or for loop with the printfs equals 0, I is less than count, I plus plus. We're just going to print each one of them. Printf, %s, %d, %d. I'll print a new line. This is going to be the same thing up here that I had here. Cut that, paste it. I'll just paste it, I guess. It's going to be printf. So what's going to be different, or why is this different with the printf than the scanf? Why do I not have to worry about the ampersands on the printf? I'm just printing it out. I'm just passing the value. I don't need the value to be written to these locations. I'm just passing the value. This should give us a hint about whether or not our thing is correct or not. But we'll go and give this a shot. So now I'm going to compile this. And then I'm going to run it, and it's going to tell me I need an argument, so I need a file, so let's make a new file. Pico, let's do this 3, cat, 10, 3, dog, 5, 5, 10, and bird, 11, 12. So, file name to write, data.txt. Doing ls, make sure we have our data.txt and our a.out. I'll run a.out on our data.txt like so. Segmentation fault, or don't. Check. When you have a segmentation fault, what does this usually mean? Means I did something wrong. That's the first thing I should tell you. What does this mean? This means that somewhere a pointer is wrong. I don't know where this pointer is going to be wrong, but it means that the pointer is wrong. It's probably, I'm going to guess, around those percentage, those ampersands that we don't really know if we want or not. How do I find it? So what I'm going to do here is I'm going to put some printfs in here. I'm going to say printf before opening file. Right? I'm going to take that printf and I'm going to copy it. I'm going to put it after this one here. After opening file, like so. I'm going to put another one here after reading file. So what I've done is I've put a bunch of these things after reading file. I put a bunch of these printfs inside of the C program. What's going to happen is these printfs are going to happen in order, right? And so I'm going to be able to tell when my error is occurring based upon what gets printed out. So before opening file succeeded, after I open the file, that means I open the file correctly. The file opens successfully. Segmentation fault before I said after reading the file. That means I probably seg faulted somewhere inside of reading the file. Oops. Let's go and open it up again. So what I'm going to do here is I'm going to put another one here. I'm going to put a printf after reading the count. Printf here, red count percent with a $D with a new line, and I'm going to put the value of count here to see if that's correct. And then I'm going to say down here, I'm going to say printf trying to read line, like so. We'll see if that prints out. Did I forget something? I did. Thank you. My GCC would have found that for me. We're almost done. Run that again. Say, so we read count was the value of 3, then we're trying to read the line, we segfaulted. That's how we can find that. We go, okay, so I know exactly where that problem is. It's probably the fact that we haven't put the ampersands on there. So let's go ahead and try to stick an ampersand on the beginning here. We'll stick an ampersand there. And we'll stick an ampersand there. We won't put an ampersand on the ash because we haven't used the ampersand on the ash before with those guys. Yeah! Yay! So that's how we don't remember if we need the ampersands or not. We're going to put some printfs in there to debug our code. We're going to do that debugging. We're going to find out where our ampersands need to go. We're going to then be able to do that and have it run. You can see there's our 3 things: cat 10, 3, dog 5, 10. So if you have any questions, please come ask me.